Welcome back. In Chapter 2, we will discuss polynomials and rational functions. In the first section, we will introduce you to complex numbers. In this section, before we introduce complex numbers, we need to introduce the imaginary unit I. Because earlier we said that the square root of a negative number is not a real number. In this section, we will be able to say what the square root of a negative number is. But first, let's define what we mean by the imaginary unit I. So the imaginary unit I is defined as I is equal to the square root of minus 1, where I squared is a negative 1. So now we can actually use this definition to evaluate the square root of a negative 4. So the square root of a negative 4 can be written as the square root of a negative 1 times the square root of 4. The square root of a negative 1 is I. The square root of 4 is 2. So we get the square root of a negative 4 is 2i. Also, let's look at another example. 3i squared. 3i squared is 9i squared. 9 times I squared is 9 times a negative 1, because we said that I squared is a negative 1. So every time you see I squared, you may substitute a negative 1. 9 times a negative 1 is a negative 9. So now we're ready to define what we mean by a complex number. So a complex number I will define as the set of all real numbers that can be expressed So a complex number is any number that can be expressed in the form a plus bi, where a and b are real numbers. A and b are real numbers. A is called the real part of the complex number, and b is called the imaginary part of the complex number. So let's look at some examples. All right, 2 plus 3i. The real part is 2. The imaginary part is 3. Minus 4 minus I. A negative 4 is the real part of the complex number, and a negative 1 is the imaginary part. One more example. 5i, let's see. We can write this in standard form as 0 plus 5i, where the real part is 0 and the imaginary part of the complex number is 5. Now that we know what complex numbers are, we can now consider operations with complex numbers. In other words, if I have two complex numbers, can I add them? Can I subtract one complex number from another? Can I multiply one complex number by another complex number? And likewise, we'll also discuss the operation of division. But let's just hold that. Let's look at what we have here. So we want to perform the indicated operations, and we want to express our result in standard form. All right, so here we have two complex numbers, and we want to add them. To add two complex numbers, well, it's what you would think. You would add the real parts, so 5 plus 3, and then you would add the imaginary parts. So you got a negative 2i plus 3i. 5 plus 3 is 8, plus a negative 2i plus 3i is 1i. So the sum is 8 plus I. And notice the result is expressed in standard form. The real part is 8, the imaginary part is 1. Let's look at the next example. Here we want to subtract. We have 2 plus 6i minus 12 minus I. All right, so to perform this operation, we want to subtract the real parts, 2 minus 12, and subtract the imaginary part. So I have 6i minus a minus plus I. So we have a negative 10 plus 7i. The real part is a negative 10, and the imaginary part is 7. The next operation is that of multiplication. Let's now find the product of the complex numbers. So if we multiply 7i, we're going to multiply 7i times 2 minus 9i. All right, so we're going to use the distributive property. So 7i times 2 is 14i. 7i minus 7i times a negative 9i is a negative 63i squared. All right, let's simplify this. So we have 14i minus 63. I squared, remember, I squared is a negative 1. So we have 14i minus 63 minus 1, a negative times a negative, is a positive 63. So the product is 14i plus 63, but remember, if we were to write this in standard form, it would be 63 plus 14i. The real part is 63. The imaginary part of the complex number is 14. So the product is 63 plus 14i. In the next example, we want to multiply 5 plus 4i times 6 minus 7i. Now to do this, we could, of course, use the FOIL method, which would be 5 times 6 is 30. 4i times 6 is a positive 24i. And a negative 7i times a positive 5 is a negative 35i. And finally, 4i times a minus 7i is a negative 28i squared. All right, let's simplify this. With 30, a positive 24i plus a negative 35i is a negative 11i minus 28i squared. So we have 30 minus 11i minus 28 times I squared. But we remember that I squared is a negative 1. So we have 30 minus 11i plus 28. Combining like terms, 30 plus 28 is 58. So we have 58 minus 11i. So the product expressed in the standard form of a complex number is 58 minus 11i. The next idea is dealing with complex conjugates to divide by a complex number. So if we're dividing by a complex number, we will need to know what we mean by a complex conjugate. So the complex conjugate, let me just say, the complex conjugate of a plus bi is a minus bi. And likewise, the complex conjugate of a minus bi is a plus bi. And when we multiply a complex number by its conjugate, so a plus bi times the conjugate of a plus bi, which is a minus bi. If you do the multiplication here using the FOIL method, a plus bi times a minus bi, we're going to get a squared plus b squared. And a squared plus b squared is a real number. So in this example, we will divide and express the result in standard form. As I said before, the goal is to obtain a real number in the denominator. So in order to begin this division, we need to determine the conjugate of the denominator, 4 minus I. The conjugate of 4 minus I is 4 plus I. So what we want to do is to multiply numerator and denominator by the conjugate of 4 minus I, which is 4 plus I. So we're multiplying numerator and denominator by 4 plus I. So now we need to do this multiplication. In the numerator, we're going to use the FOIL method. 5 times 4 is 20. 4 times 4i is a positive 16i. And I times 5 is a positive 5i. And 4i times I is a positive 4i squared. All divided by the product of the conjugates. 4 times 4 is 16. We expect this to be a real number. That's what we said. Let's just do the multiplication. So we have a negative 4i, a positive 4i, and a negative I times I is a negative I squared. And as we see here, a negative 4i with a positive 4i cancels. So we have 16 minus I squared in the denominator. Simplifying the numerator by combining like terms, we have 20. 16i plus 5i is a positive 21i plus 4 times, here again, I squared we know is a negative 1. So that's 4 times a negative 1. We have 20 plus 21i. Positive 4 times the negative 1 is a negative 4. All divided by 16 minus, again, I squared is a negative 1. Simplifying in the numerator, combining like terms. 20 minus 4 is 16 plus 21i. In your denominator, you have 16, a minus times a minus. 16 plus 1 is 17. And if we were to express the result in standard form, we have 16 divided by 17 plus 21i divided by 17. So what we have in standard form, so the quotient upon dividing, the quotient is 16 over 17 plus 21i divided by 17. In this section, we will discuss roots of negative numbers. For any positive real number b, the principal square root of the negative number b, a negative b, is defined as the square root of a negative b, and it's defined as I times the square root of b. So let's look at a couple of examples, roots of negative numbers. So in the examples presented here, we will perform the indicated operations and write the result in standard form. The first example is to add the two radicals. So what we have is the square root of a negative 27. So we know that that's going to be I times the square root of 27 plus I times the square root of 48. So the next step is to simplify each radical. The square root of 27. The square root of 27 can be expressed as 9 times 3 plus I times the square root of 48 can be expressed as 16 times 3. The square root of 9 times 3 is the square root of 9 times the square root of 3. The square root of 9 is 3, so we have 3i times the square root of 3 plus the square root of 16, 16 perfect square, so we have 4 times I times the square root of 3. So we can actually combine these, they're like terms. 3i plus 4i is 7i times the square root of 3. In the next example, we want to square a -2 plus the square root of a -3. We're going to square this. You can either use the FOIL method, or you may recall how we expand a binomial. So if we square the first term, a -2 squared plus, we're going to multiply a -2 times the square root of a -3. Let's deal with the square root of -3. We said that the square root of a -3 is going to be I times the square root of 3. So if I multiply this by a -2, so I have -2 times the square root of I times the square root of 3 times a -2. So I need to now multiply this by 2. Because when you expand the binomial, let's say if this had been A plus B squared, you're going to square the first term, that's A squared. You get a product of the two, AB, and then double that. Multiply by 2, so that's 2AB plus, square the last term, B squared. So in this example, we multiply a -2 times I times the square root of 3 times 2, times 2, times 2, plus the square root of I times the square root of 3 is going to be, so now I have to square the I times the square root of 3. We still have to square that. So what do we have here? We have a -2 squared, which is 4. And we have a -2i times 2 is a -4i times the square root of 3. Plus, if I square I times the square root of 3, I'm going to get 3i squared. Square root of 3 squared is 3, and I times I is I squared. Let's simplify what we have here. So we have 4 minus 4i times the square root of 3 plus 3 times I squared is a -1. So we have 4 minus 4i times the square root of 3. Positive 3 times the -1 is a -3. Combining like terms, 4 minus 3 is 1 minus 4i times the square root of 3.